Okay. Good morning to all. So now we are discussing the second part of unit number second, that is the seepage analysis, which contains the first one, that is the seepage velocity and discharge velocity, that is the expression for the seepage velocity and discharge velocity. Then the seepage pressure, so expression for the or derivation for the seepage pressure, and the quicksand condition or quick condition or boiling. So the expression for quick condition, then the next, or which is also called as a critical hydraulic gradient. So what is the definition for critical hydraulic gradient? What is the formula for critical hydraulic gradient? That is IC. Then the Laplace equation for 2D flow. It is analytical equation for the two-dimensional flow. The expression or derivation for the two-dimensional flow. Then the last one, that is a flow net. Okay, flow net is a graphical representation of a 2D flow. Okay, so we are starting with the first one, that is a seepage velocity. So what is meant by the seepage velocity? So seepage velocity, it is the actual velocity of the flow which is passing through interconnected voids of the soil sample. So this seepage velocity, which is denoted by letter Vs. So V means the velocity, S for seepage, that is Vs, that is seepage velocity. So while deriving this equation, seepage velocity, so we know that according to the continuity equation. What is the continuity equation? Continuity equation states that Q equal to AV, that is area into velocity. So here we can write as Q equal to AV into Vs in terms of area of voids and velocity of the, that is Vs, that is the seepage velocity. So here I am writing so A into phi equal to AV into Vs, AV into Vs. So what is the value of the AV now? So what is the value of AV now? So what is the value of Vs now? That is we want to calculate the seepage velocity. So Vs is equal to, so Vs equal to, that is it comes down to the numerator, and this value comes on the denominator, that is A into V upon AV, A into V upon AV, okay, or A into V upon, that is A into V upon AV, that is area of the voids, or we can also write as A upon AV into V, A upon AV into V, A upon AV. Okay, are you getting? That is this derivation which is derived from continuity equation, that is Q equal to AV, that is A into V. Okay, so A into V, that is in terms of seepage velocity, that is AV, that is area of voids, into Vs, that is seepage velocity. Okay, so what is the intensity of Vs now? So Vs is equal to, that is A into V, Vs equal to A into V upon AV, that is area of voids. Okay, so if you write like that, that is A upon AV into V into V. So here clearly shown, that is Vs equal to V into A upon AV. Okay. So now that is Vs equal to V into A upon AV. Now we are multiplying and dividing this term, that is this pink color term, that is Vs equal to V into A upon AV, this term multiplying and dividing by L. So we get Vs equal to V into AL, V into AL upon AV into L, AV into L, that is that is V S equal to phi into A into L upon AV into L. Okay, because we are multiplying and dividing this is second term by L. So this we know that A into L, that is called as volume. Volume means nothing but the area into length or area into height. So here we can write as A into L as phi1, A into L as phi1, that is volume, and AV into L, this is also volume, that is this is also volume, but this is the volume of voids because it contains area of voids, it contains area of void. So upon phi upon phi v, and into this term is right as it is, that is phi s equal to phi into phi1 upon phi v. So phi1 is nothing but area into L, that is that is called as a volume. So volume, so here we can write as volume as v1, and AV into L, that is area of voids, into L, that is volume of voids, we can write as phi v. Okay, but we know that porosity, we know that porosity is a ratio of volume of voids to the total volume. So porosity, what is the formula for the porosity? It's the volume of voids to the total volume, Okay, so this formula becomes phi s equal to phi right as it is into so this term is equal to phi v upon v, that is 1 upon n, because 1 upon n, because here is volume is on numerator and volume of voids is on denominator. So that is equal to 1 upon n, this 1 upon n equal to volume of voids to the total volume. Okay, total volume. So our formula will be that is phi s into phi, that is phi s equal to phi into 1 upon n, that is phi s equal to phi by n, but this phi by n so here we, that is phi s equal to phi by n, but this k so this phi by n, so here is phi, that is we know that phi, that is according to Darcy's law, v equal to k into I, according to Darcy's law, v equal to k into I. So here we can also write as vs equal to k, vs equal to v upon n, that is so vs last term, that is vs equal to phi upon n, that is ki upon n. So vs equal to ki upon n, but this ki upon n is called as kp, this ki upon n which is called as a kp, but this ki upon n, that is called as a kp, that is equal to kp, that is coefficient of percolation, that is Vs equal to kp, that is coefficient of percolation into I, that is hydraulic gradient. So this is the expression for the seepage velocity. Okay, I am explaining once again. So what we do here, so first of all we know that according to continuity equation q equal to av, that is area into velocity. So in terms of the seepage velocity, you can write we can write as av into Vs. Okay, av into Vs. So Vs equal to phi into a upon av, because so so this Vs, because a v into a equal to av into Vs. So Vs will be equal to, ये टर्म आपका न्यूमरेटर को जाएगा और ये बाकी का टर्म आपका डिनोमिनेटर, दैट इज AV into Vs, AV into Vs. So AV into Vs. Okay. So AV into V, sorry, AV into V, because in terms of seepage velocity we are finding it. Then divide and multiply this term by L, divide and multiply this term that is this pink term, that is Vs equal to V into A upon AV, that is V into A into L, that is multiplied by numerator by L and denominator by L upon AV into L. But we know that A into L is that is called as a volume. So here we can call write as volume as V1, and AV into L is also volume, that is volume of voids, that is V1 upon V. But we know that formula for the porosity is volume of that is volume of voids to the total volume. So our formula becomes Vs equal to, our formula becomes Vs equal to V into 1 upon N. So we can write as Vs equal to V upon N, Vs equal to this V upon N, Vs equal to V upon N. So but here we are putting phi equal to k into I according to Darcy's law. We know that Darcy states that phi is directly proportional to the I, that is V equal to ki. So here we write as Vs equal to ki upon N, ki upon N. But this ki upon N term, which is called as kp, that is kp, sorry this ki upon this k upon n, this k upon n term, this k upon n term which is called as a kp, that is coefficient of percolation, coefficient of percolation. So our final formula becomes Vs equal to this k upon n, that is kp, that is kp, that is k, sorry, so phi we know that this kp equal to k upon n, but our formula is Vs equal to ki upon n, but this k upon n is nothing but the kp. Okay, so our formula for Vs will be equal to k upon n, that is our kp, and this into I. Okay. So from that the next definition, that is the discharge velocity. It is not an actual velocity which is passing through interconnected voids. Seepage velocity is the actual velocity that which is actually passing through the interconnected voids, but this discharge velocity, it is theoretical velocity, or it is a fictitious velocity which is obtained by total discharge by total cross sectional area. Okay, so how we can obtain this discharge velocity, that is Q equal to A into V. So V equal to Q upon A. So this V is nothing but our discharge velocity, and the seepage velocity is Vs. It is actual velocity. It is actual velocity where this water that actually passes into the soil sample or actually passes into the interconnected void, and this discharge velocity, it is only theoretical velocity. It is only theoretical. It is not an actual velocity which is passing through the interconnected void. So this discharge velocity can be calculated by using continuity equation, that is Q equal to A into V. So V equal to Q upon A. According to this formula, we can define the discharge velocity as total discharge of the soil, total discharge per unit total cross sectional area of the soil sample, which is called as a discharge velocity, and its unit is also same as meter cube per second, meter cube per second. Okay. So the next point is the seepage pressure. That is, seepage pressure means the pressure which is exerted by soil to the water. Pressure which is exerted by soil to the water through which it percolates, which is termed as seepage pressure. Means the pressure which is given by soil to the water through which actually it percolates, which is called as a seepage pressure. So this seepage pressure is denoted by letter letter PS. Okay, as we know that this pressure is equal to as we learn in fluid mechanics, pressure is equal to head into unit weight of the water, head into unit weight of the water. Okay, that we had already learned in fluid mechanics. Okay, so PS equal to H into gamma W. Okay, then we are multiplying this term into by L. So here we can write as PS equal to H upon L into L, H upon L into L gamma W. Okay, but this H upon L is nothing but the hydraulic gradient. H upon L, that is a total height per unit length, which is called as a hydraulic head or hydraulic. So the H is hydraulic head, and L is the length of the soil sample or length over which the head is lost. So H upon L is nothing but I. So we can write as PS equal to IL into gamma W, IL into gamma W. So I is hydraulic gradient and gamma W is nothing but the unit weight of the water. So now we can write the expression for the seepage force. Okay, so what is the seepage force? We know that the stress, equal to force upon area. So what will be the force? So force will be equal to stress into area. Force will be equal to stress into area. So this force is nothing but our pressure. Force is nothing but our pressure. Force is here is force. We can write as force as Fs, and this pressure is our PS, that is seepage pressure, that is your stress, and A is area of the soil sample. So as we already know that so by going stress equation, Fs equal to PS into A, but we know that PS equal to IL into gamma W. So here we are writing PS is IL into gamma W, which is shown by this blue pen, that is IL into gamma W. So Fs, that is force, according to stress equation, stress equal to force upon area. So force equal to stress into area. So here stress is our pressure, that is PS into A. So PS is IL into gamma W into A. So where this A is called as the total area of the soil sample, and the seepage force. Now what is the intensity of a seepage force per unit volume? Seepage force per unit volume, that is Fs per, that is Fs per unit volume is equal to, as we know that, so seepage force equal to IL into gamma W into A, IL into gamma W into A, and per unit volume is nothing but area into length, which is called as volume. So here we are cancelling the area, L. So seepage force per unit volume, its value will be I into gamma W only, I into gamma W only. Okay, so note that this seepage force always act in the direction of the flow, So in terms of the effective pressure, the soil mass, which is given as that is effective pressure, that is when the flow is upward. So the formula for effective pressure, okay, that is L gamma W plus minus PS plus minus PS, that is P, that effective pressure, that is P equal to L gamma L gamma dash, this gamma dash is a submerged unit weight, it is a submerged unit weight, that is gamma dash plus minus, so we know that value of PS is IL gamma W, okay, this value is IL, that is which is shown by this blue pen, that is IL gamma W. So when the flow is downward, so our formula for effective pressure is not that this formula, it is very important for your online examination. What is the formula when the flow is downward, what is the formula when the flow is upward for the effective pressure, what is the formula for seepage pressure, what is the formula for seepage force, what is the formula for seepage force per unit volume, so you have to keep in mind, so all this formula. So when the force is downward, effective pressure will be L into gamma dash plus, so note that here plus sign they were using, L gamma dash plus IL gamma W, and when the flow is upward, the formula becomes PE equal to L gamma dash minus IL into gamma W. Okay, so next point is okay. So this next point is we later discussed, that is a quicksand condition. Okay, so now no problem, we are discussing now. So quicksand condition or quick condition or boiling. Okay, so when the flow of the water is in upward direction instead of the downward direction. Okay, so this condition, which is called as a boiling condition or quick condition, as we know that in the most of the cases, in case of the when the flow of the water from one place to the another place, which is happening from, suppose this is A point and this is a B point and this is a soil sample. Okay, so when the flow of water from one place to the another place under the action of gravity, which is happening, in the most of the cases the flow of the water is from upward direction to the downward direction, upward direction to the downward direction under the action of gravity. Okay, which is called as a permeability, okay, but sometimes what will happen when the flow of the water which is from B point to the A point, which is B point to the A point, means the flow of water from downward to the upward, that is we can also call it when the flow is upward direction, flow is in a upward direction, flow of the water is in upward direction, which is called as quicksand condition or quick condition or boiling condition. Okay, so this condition is generally observed in a sand. This condition is observed in a sand, and the reverse condition, that is heaving, which is observed in a clay. Okay, heaving which is observed in a clay, and the gradient which is used for the quick condition or quicksand condition, which is called as a critical hydraulic gradient. A gradient which is used for quicksand condition, which is called as a critical hydraulic gradient, that is IC. Okay, so note that during this condition, effective pressure, that is PE, reduced to the zero, that is effective pressure which is equal to 0. Okay, effective pressure will be equal to 0, and we know that for this quick condition, flow is upward. So when the flow is upward, what will the formula? Flow is upward, formula will be PE equal to L gamma dash minus IL into gamma W, okay, or we can also write as PE into L gamma dash minus PS, because with the here flow is upward. Okay, flow is upward, so here is write as V equal to L gamma dash minus IL gamma W is nothing but our PS, that is L gamma dash minus PS, because flow is in upward direction. But for quick condition or quicksand condition, for quick condition, the flow is in upward direction, that is P equal to L gamma dash minus PS, that is PS is nothing but that is IL into gamma W. Okay, so for quick condition, the effective pressure is 0, that is PE equal to 0, that is PE equal to 0. Okay. So this PS will become because this value is 0, so PS will become L into gamma dash, L into gamma dash. Okay, but this PS is nothing but IL gamma W into L gamma dash, IL gamma W equal to L gamma dash. So L become cancel, L become cancel. So formula will be I gamma W equal to gamma dash, I gamma W equal to gamma dash. Okay. So in terms of I, so this value comes for numerator and this value comes for denominator. So I equal to gamma dash upon gamma W, gamma dash upon gamma W. So we know that the formula for gamma dash, that is submerged unit weight. Okay. So we know this formula, we had already learned in unit number first, that is the expression for submerged unit weight, that is gamma dash equal to, that is G minus 1, sorry, gamma dash equal to G minus 1 upon 1 plus E into gamma W, into gamma W. Okay. So put this formula into this equation, that is I equal to gamma dash upon gamma W. So formula will be equal to I equal to, so I equal to gamma dash upon I equal to gamma dash upon gamma W. So gamma dash formula is G minus 1 upon 1 plus E into gamma W upon gamma W upon gamma W. So this gamma W get cancelled. So formula will be of I will be G minus 1 upon 1 plus E. Only this term is remain. Na? So I equal to G minus 1 upon 1 plus E. Note that this is very important formula and you have to solve 2 marks problem for that. Okay, when there was theory examination, most of times problem based on this formula is were asked for many times. Okay, so this formula in terms of void ratio will be IC equal to G minus 1 upon 1 plus E, and in terms of porosity the formula will be G minus 1 into 1 minus N. Okay. So remaining part we will discuss later.